Thank you, everybody, for being here with us today. And I have the pleasure to kick off this course with illustrious people. So first of all, I felt we need to start by a definition of the metaverse. And I found that Matthew Ball, in his recent book, has done a perfect job of defining the metaverse, as you can read there, to massively scale an interoperable network of real-time rendered 3D worlds that can be experienced synchronously and persistently by an effectively unlimited number of users with an individual sense of presence and with continuity of data, identity, history, entitlements, object communication, and payments. It's a mouthful, but I think it's very interesting that at least we frame the conversation by a definition. But the thing is, all of us are expecting the metaverse to be open, fair, and safe for ourselves and our children, of course. And clearly, the metaverse, as per this description, does not exist yet. But the work of the computer graphics pioneers and industry members, your work, over the past 50 years sets a foundation on which a network of 3D virtual worlds can and will be built. It will happen, we will make it happen. In 1969, when John Mates named the Special Interest Group in Graphics SIGGRAPH, he made sure to call out interactive techniques as well, back in '69. So real-time 3D is the core enabling technology of virtual worlds, and therefore of the metaverse. So we, the SIGGRAPH people, have a very important role to play in building up and shaping up the metaverse. For the metaverse to be as successful and as ubiquitous as the internet itself, it needs to reach scale and utility. It needs to become accessible to everyone and provide value to users. Achieving both scale and utility will require the acceleration of the commoditization of real-time 3D creation and playback. Real-time 3D is naturally at the core of games and simulation, but aided by the progress of AI, real-time 3D has also recently transformed the techniques and methodologies to create linear content and stories of the highest quality. So the extension of existing standards and or the creation of new standards for the authoring and transmission of fully simulated worlds is needed to accelerate the adoption of real-time 3D and its commoditization. One of the core values attributed to the metaverse is the ability for users to wrestle away ownership of their data and particularly of their digital goods from closed platforms. Interoperability and open standards will be required to achieve this independently of the economic or transaction models that will prevail. So during this course, presenter will share a multiplicity of point of view and perspective on what the industry needs to do, should be doing to set the basis so that anybody can create and share environments, objects, characters, stories, and interactive connected experiences. In interoperability and open standards will require a lot of discussion and coordination across many industry players and standards defining organizations. That's why we created the Metaverse Standards Forum to host this conversation. So our ambition for this course is to contribute to the conversation and allow you, the attendees, to form opinions, identify opportunities and initiatives necessary to lay the foundation of the open metaverse. I will leave you with a quote from Neal, the president of the Kronos Group, who will close this class this afternoon. When we were pitching the Metaverse Standards Forum to folks in the industry, and they were telling us, isn't that a bit early? They meant foolish, really, to try to standardize something that does not exist. And to which Neal, in his legendary calm, would answer, we do plan on building cathedrals, but what we need to do now is to agree on how we bake the bricks. And I think that's what we should be doing together, learn how to bake the bricks together. So that's our goal for today. And to kick off this class, Patrick and I thought it would be great to hear from the guy who dreamt and named the metaverse. He's an amazing and prolific author. He wrote Snow Crash, of course, but also many other amazing books. He's also a hands-on technologist who worked at Blue Origin and Magic Leap. And today, Neal Stephenson is here and we'll talk about the metaverse, then, now, and next. So please join me for a warm welcome to Neal Stephenson.
Thank you. This is the cover of a new edition of the book that's coming out in November to commemorate the 30th anniversary. So I'm going to start with a few minutes trip down memory lane. Part one, then 32 years ago, I attended SIGGRAPH in Dallas. For a couple of years, I'd been working with an artist named Tony Sheeter on a graphic novel entitled Dioxin Posse. We had got interested in the potential of computer graphics as a way to generate the artwork. I gave him my old Mac SE and bought a Mac 2, the first color Mac. Even then, it was possible to make color scans of photographs and get them into the computer. I had an idea that photos could be digitally processed to make them look more like comic book images. Usually in comic book art, there's an outline surrounding an object which is filled in with a solid color. I figured I could use edge detection algorithms to establish the outlines. Filling them in with solid color was a more challenging project, but I had a notion that if I converted the pixels from RGB to HSV, jacked up the saturation, and then converted back to RGB, I might end up with something that looked sort of comic booky. So I wrote a program in C that did that. And when I ran the program against the 480 by 640 pixels pixel images that completely filled the screen of my Mac 2, it took hours. So I needed more computer power. By this time, I had moved to Alexandria, Virginia. I became aware that there was a connection machine at the University of Maryland in College Park. I acquired the manuals for the connection machine, a big pile of 3-ring binders, and studied them for a while, but realized that it wasn't going to work because in those days, the highest bandwidth way for me to get my data to the connection machine would be to throw my computer in the back of a car and drive around the Beltway for an hour. I'd become aware of the existence of transputer boards that could be inserted into the expansion slots of a Mac 2. These were CPUs designed for parallel processing. They ran a special language called Occam, so I bought one and learned Occam. So at this point, the front end was all written in C++ using the Macintosh Programmer's Workshop and generally hewing to the Apple user interface guidelines. But once you had decided how you wanted to process a given image, you could hit a button and send the job to the transputers. All of this predated Snow Crash, but there was one character from the Dioxin Posse story who later found her way into the pages of that novel. She was a skateboarder, and it was of the essence that her skateboard be capable of managing irregular surfaces. I had the idea that this would be possible if the wheels consisted of telescoping spokes. I tried to model these with a 3D package that turned out to be bad, but somehow I had become aware of RenderMan. A version was available for the Mac. I got Steve Upstill's The RenderMan Companion, and it became obvious that I could produce a model of the skateboard's wheels much more easily just by writing some C code that would generate the necessary primitives using the RenderMan libraries. So some of that imagery made its way into the project, and as a side effect, I learned a few basic things about shaders and so on. My original idea for making photographs look like comic book art never actually worked, but once I got all of this stuff up and running, I found that there were a lot of other ways that I could manipulate images to produce cool-looking effects. Tony and I used those to produce a few sample pages of our proposed graphic novel. He would print them out on a color dot matrix printer and paste them up on poster boards at large format, then reduce the images photographically. We took the resulting layouts to New York and pitched them to publishers, but were unable to sell the idea. It did occur to me that if this system could generate one image, it could generate more, and if you string those together, you have a movie. So I bought a professional-grade 3/4-inch video tape recorder, a frame grabber, and a rack-mounted box that could control the VTR in response to commands issued by my software. Since I only had one VTR, I had to use the same tape for input and output. I'd rewind the tape to a particular frame number, grab the frame, process it, advance to a blank place on the tape, and output the new frame there. By running this process for days or weeks at a time, I could produce digitally reprocessed video. Tony named the machine Jethro because the clunking sounds made by the VTR as it shifted back and forth reminded him of a hillbilly sitting in a dark room pumping a shotgun. As a side effect of all this, I had come to the attention of the company that manufactured transputers. They were going to be showcasing their products in a booth at SIGGRAPH in Dallas in the summer of 1990, and they wanted to have a few people there who were actually using transputers to solve problems. They invited me to come, and I did. My project made not a ripple at SIGGRAPH. As luck would have it, our booth was directly across a narrow aisle from that of the New Tech video toaster, a product that was being repped by a famously charismatic spokesperson. So I spent the whole duration of the show looking at the backs of the heads of attendees who were flocking to the New Tech booth. Since I was obligated to staff the booth, I didn't attend many presentations, so I missed one whose description I'm going to read now from the official proceedings. Special session, hip, hype, and hope, the three faces of virtual worlds. Chair, Bob Jacobson, University of Washington. Panelists, John Perry Barlow, author and songwriter. Nolan Bushnell, Esther Dyson, Tom Furness, Human Interface Technology Lab. Timothy Leary, Warren Robinette, University of North Carolina. Randall Walser, Autodesk. By now, almost everyone in computer graphics has read, seen, or experienced virtual worlds, artificial realities generated by computers which surround the user. Virtual world systems are the focus of the media, grist for the TV mill, and everyone's pick as the big idea of the 1990s. But what does it all mean? Is virtual worlds technology really that important? Panelists address the artificial reality controversy and suggest the future of professional and personal computer use. Even though I missed that session, which must have been fascinating, I don't think it made any effective difference as far as the metaverse was concerned. Although I was working alone, pre-internet, and mostly isolated from the kinds of people who show up at SIGGRAPH, I had learned enough about RenderMan to get the idea. You could use code to generate renderings of three-dimensional scenes whose underlying description was written in an abstract formalism. On the hardware side, developments such as the connection machine and transputers suggested that the rendering of such scenes would continue to get faster. With Jethro, I had already made the jump from individual still images to moving pictures. Even the Apple user interface guidelines played a role in that they laid down a framework for building apps that could be quite diverse while sharing a common set of UI primitives. All of this hinted at a future still pretty far away in 1990, but easy to imagine, in which immersive three-dimensional environments became a new communications medium. Having set fire to a big pile of money acquiring the hardware for this project, I became fascinated by the question of how the price of hardware might be brought down to a level where it was within reach of typical households. Something similar had happened during the 1950s with television. A feedback loop somehow got started whereby the popularity of certain programs caused more people to buy televisions, which drove their price down while giving manufacturers incentives to invest in larger screens and higher quality. The metaverse was my conjecture as to what might do for 3D computer graphics what I Love Lucy had done for television. So I wrote the book. As it happened, what actually brought the cost of graphics hardware down was video games, in particular Doom, which came out the year after Snow Crash was published. That and the many games inspired by it caused the video game industry to grow to the point where its revenues have long since eclipsed those of Hollywood. The World Wide Web came into existence at the same time and led to the explosive growth of the internet. It also sold a lot of computers and graphics cards to users who wanted to be able to see pictures and videos on their screens. Those two factors made computer graphics cheap and ubiquitous without the need for a single metaverse as described in the novel. At the risk of seeming entirely self-centered, I'll mention that some of my subsequent books also talked about immersive experiences and how the underlying plumbing might work. The success of Snow Crash, at least among the geek population, brought me into contact during the mid-1990s with privacy and crypto enthusiasts, loosely calling themselves cypherpunks. During my occasional encounters with them, I would hear about their ideas for anonymized, decentralized communication on the internet. That influenced the storyline of my next book, The Diamond Age, the plot of which makes no sense unless you assume the existence of fully anonymized, encrypted, decentralized communication and payment systems. The next book after that, Cryptonomicon, is explicitly about cryptocurrency. The series of books after that, The Baroque Cycle, is in part an extended riff about the origins of the modern monetary system. Skipping ahead to Reamd in 2011, that's a whole book about a fictitious video game, T-Rain, that's based on financial plumbing that uses real money. Part 2, now. So fast forward 32 years. In order to achieve what I was thinking about in 1990, namely to get millions or billions of people using the metaverse, we need to create experiences that people enjoy having. There are people who are good at that. By and large, they are employed in the game industry, or increasingly film and television, which are making use of game engines, a trend that was heavily accelerated by COVID and the restrictions it placed on the movement of talent around the world. The basic problem to be solved in all creative industries is how to get artists to make art in a coherent, coordinated way. And by artists, I'm including people who work in various roles in the game and web dev industries, not just the obviously artistic jobs such as texture artist or animator, but game designers, programmers, and so on. Sadly, from the point of view of investors and executives, this involves paying them money. The only consolation for this tragic fly in the ointment is that there might one day be a return on that investment. With occasional heartening exceptions, investors try to pay the artists as little as possible while steering their creative output in the directions that involve the least financial risk, which is how we end up with an endless stream of nearly indistinguishable superhero movies, free-to-play mobile games, etc. From the standpoint of the artist, this boils down to getting someone to write them a check, and it is an eternal source of wonderment how well-heeled companies and financiers who never stop proclaiming their adoration for the creative process and their excitement about specific projects suddenly disappear when it comes time to pony up the dough. Anyone who reflects on this for very long will find themselves wondering what is the point, after all, of the whole apparatus of studios and publishers. Traditionally, these entities are banks that, at least in theory, can finance creative productions. But that just means a reservoir of money. The reservoir has to get filled from some source. Ultimately, that source is the individual viewers, readers, gamers, etc., who are en masse making small individual payments in exchange for experiences that they like. The executives who control the reservoir then decide where to place their bets on the next round of creative production. Pre-internet and pre-game industry, creative industries did actually need an intermediating layer of executive decision-making and bet placing. Those executives were acting as professional stand-ins for the tastes and preferences of mass audiences whose only way of sending data back up the chain was to buy a ticket for a movie or not. Wouldn't it be great if we could replace those executives with data pipes, since that's all they really are? In the early days of the internet, many of us believed that this would happen and that artists would get paid directly by fans. This didn't work out, at least in the case of music. First there was bootlegging, then streaming services. While it is true that musicians can get payments from streaming services, those payments tend to be very small. Between that and the COVID shutdown, it has been a bad few decades for musicians. For them, the internet looks like a shitty deal, a massive transfer of money away from artists. How can we prevent history from repeating itself in the case of artists who contribute their work to the metaverse? There is an answer from the crypto world, NFTs, which can make use of blockchains to publicly assert that a particular artist created a particular collection of bits no later than a particular time. Connected with those, we have smart contracts, which can, in theory, channel payments to those artists. There are some caveats, at least in NFTs, as they first came to prominence circa 2021, and I'll get into that topic later. First, though, rather than talking about this from a defensive crouch, I'd like to focus on the desired vision. And for that, I'm going to quote from Jaron Lanier, who is trying to solve the problem of crypto that doesn't build, as opposed to crypto that merely concentrates. In essence, he's drawing a contrast between pure speculation, a common accusation leveled against crypto, versus actual creation of economic value. How do you structurally incentivize creation as opposed to speculation? When the creative works sold as NFTs are disembodied collectibles, the economy arising from their sale and resale can seem like mere speculation. Opinions may differ on whether that is okay. People have traded in collectibles such as comic books, coins, and stamps since long before the internet. Again, I tend to come down in favor of anything that leads to artists getting paid, and a lot of artists are making money from NFTs. But it's neither here nor there as far as the metaverse is concerned, because metaverse experiences can't be assembled from disembodied collectibles. They have to be engineered. Part of that is, to be sure, the creation of assets in the game industry sense of that term, 3D meshes, sound files, particle systems, and so on. But merely dragging assets into a folder doesn't create an experience any more than stacking a bunch of lumber, wire, and appliances on an empty lot makes a house. Thus, we find our way into the interconnected topics of blockchain in games, NFTs, and interoperability/composability, which has been controversial of late. Let me just say the following. NFTs are purely digital objects. Under the right conditions, however, purely digital objects actually can be assembled into things of legitimate, creative, and economic value. They're called games. A framework that allowed digital objects on the chain to interoperate as in a game would be an engine of genuine creative and economic value, and as such should be safe from the accusation of being mere speculation. Interoperability, along with the use of cryptocurrency and NFTs, has become a flashpoint on social media during the last year. A lot of people feel compelled to take stances on it, because that is how your brain harvests dopamine from the internet. Post a take on something and wait for the likes to roll in. I'm more of a wait and see kind of guy. As Marcus Aurelius said, it is in our power to have no opinion about a thing and not to be disturbed in our soul, for things themselves have no natural power to form our judgments. Some of these negative takes are rooted in blanket objections to crypto, which I don't have time to address here. This is a computer graphics, not a crypto conference. Setting that aside for now, many game devs have expressed hostility toward interoperability proposals on two main grounds, technical and aesthetic. The most succinct statement I've heard relating to the aesthetic objection comes from Mark Long, founder and CEO of Shrapnel, who put it this way: "We're not saying that you should be able to bring your sniper rifle into a soccer game." Many games are coherent works of art that take place in fully realized fictional worlds. It's the life work of the people who make such games to see to it that every detail of the art direction, music, sound, and gameplay are consistent with a unifying creative vision. When advocates of interoperability, typically crypto bros with a certain ideological axe to grind, show up in their feeds demanding to be able to bring extraneous game objects into their worlds, it feels disrespectful. It feels that way because it is. There is, however, a huge and thriving market for games that are creative mashups. Three of the best known are Roblox, Minecraft, and Fortnite. Fortnite has continued to engage users by pulling in IP from a wide range of pop culture sources. There's nothing unusual there about seeing a four-person team consisting of Iron Man, John Wick, the Silver Surfer, and a blue banana. No one is the least bit troubled by this. It's part of the fun. What's interesting about that overall look and feel is that it is essentially metaverse-like. The metaverse, as described in Snow Crash, is just such a creative mashup. The answer then to the aesthetic objection goes something like this. The metaverse is big. It contains multitudes. There are going to be public spaces that are mashups, but there will also be specific zones where different rules apply. You could think of these as being analogous to a Renaissance fair. When you go and visit a Ren fair, you're agreeing to buy into a particular aesthetic that only applies within the boundaries of that event. You're willing to do that because you enjoy pretending to live in a medieval village for a couple of hours. It's interesting to think about how the equivalents of Ren fairs might be established in the metaverse and how the art directors and game designers of certain spaces might be empowered to assert editorial control over the avatars and game objects that are capable of being manifested in those spaces. When you step over the boundary of a metaverse property into a medieval world, the lightsaber and blaster might disappear from your inventory or be grayed out, or even be replaced by objects of somehow equivalent value that are germane to that world. Ideally, this creative control ought to work in both directions. As I've just pointed out, the proprietor of an experience might want to ban certain objects from being brought in, but the creator of an object might prefer that their work not be used in certain kinds of environments. For example, if I've created an avatar that's childlike in appearance, I might be perfectly happy to see it used in kid-friendly environments. But if it showed up in certain other kinds of environments, it would suggest that something creepy was going on. This sounds hard to implement in an open system, and maybe it is, but it's being worked on, and I'll circle back to it later. The basic technical objection to interoperability I've already mentioned. You can't just drag and drop assets from one game to another. People who think that don't know anything about games. There are a number of ways to attack that technical problem. I don't pretend to be aware of all of them. This is an active enough field that I don't think it's possible simultaneously to stay on top of everything that's being done and to actually do anything. In the next and final part of the talk, though, I'm going to mention some conversations I've been having with people who are working in related areas. By way of full disclosure, I'm doing this in my capacity as a co-founder of Lamina One, which is a startup dedicated to launching a layer 1 blockchain aimed at exactly these sorts of applications. I'll make other disclosures as I go. Part 3, next. Bcopy. Disclosure, I'm about to become a customer of Bcopy. It's spelled B-K-O-P-Y. The NFTs that hit the market during the boom of 2021 look to have been hot-wired together from then available constructs in the blockchain and cryptocurrency world. It's a first-generation product that needs to become a lot more fully baked. This is being worked on by Josh Kramer in the Seattle area. He's the former head of motion picture business operations at Amazon Studios, and as such had a kind of Olympian perspective on matters having to do with IP agreements, but he has also known how to code from a young age. Josh has actually done the hard work of reading through the fine print, such as it is on existing NFT marketplace agreements, trying to pin down exactly what, if any, rights are being transferred to the buyers. And it's a mess. Sellers aren't making representations that they actually own the artwork being transferred. In the case of allegedly limited edition runs, they aren't making any legal commitment not to just crank out more of them. Buyers aren't really coming away with clearly defined rights as to what they've bought and how they're allowed to use it. And exactly what they're buying isn't really clear anyway, because putting actual assets on the chain is at the moment economically prohibitive. Consequently, the on-chain components of traditional NFTs, the data that can actually be verified by inspecting the online ledgers, are mostly pointers to files stored off-chain, typically an IPFS, interplanetary file system. The drawback, as many have pointed out, is that the files pointed to can be altered or even disappear altogether. If that happens and the thing you bought and paid for is only defined as a certain pointer into IPFS, do you still own anything? What is it? Do you have any rights? To make an analogy to real-world property transactions, if someone is trespassing on your land and you call the sheriff and ask for them to be arrested, the sheriff's ultimate source of authority for doing so resides in a legal document, a deed that gives you ownership of that land. If you were to buy a piece of property using a blockchain transaction, as those are currently structured, you would definitely be spending the money, but you wouldn't actually get legal ownership of anything because the law would not recognize a smart contract as a source of truth for real estate ownership. Until that changes, how can blockchain transactions that are concerned with non-blockchain assets be legally enforced? That's the problem that Bcopy is addressing. It's a technology for binding a token to an enforceable legal agreement. In this system, a legal contract, a legit binding agreement, is posted in its entirety on the chain once. The cost of publishing one page of text to the Ethereum blockchain can be as high as $500, depending on the gas price and the Ethereum price at publish time. So easily thousands of dollars for a document long enough to contain an enforceable legal agreement. But in the Bcopy scheme, that only needs to be posted once. Subsequent transactions are recorded on the chain as much smaller NFTs that simply refer back to that original agreement. Buyers, therefore, know exactly what they're buying. Both buyers and sellers are making legally binding representations spelled out in the agreement. The seller, for example, might state that they are only selling so many copies of a given NFT and that this number will never go up. Sounds obvious, but it's absent from many existing transactions. The buyer might represent that if they resell the artwork to someone else, they'll pass a percentage back to the original seller. That's also a common feature built into many NFT smart contracts, but not in a legally binding way. Is this relevant to the metaverse or only to the NFT market? Well, you might remember earlier I was talking about why it might be important for an artist, the creator of a game object, to be able to exercise some control over where it was used. There are a lot of ways in which that could be important. If I'm a visual artist and I sell something, my expectation is that the buyer might display the artwork in their home, real or virtual, or hang it on the wall of an office, or in some other way display it privately in a location associated with them. But if they turned around and used it as the logo for a new product, then I'd expect to be compensated for that. And if I disapproved of the product for some reason and didn't want to be associated with it, I'd like to have veto power over that usage. So when bcopy inserts binding legal agreements into NFT transactions, it's about more than just the art market. They're actually pioneering new features that are going to be foundational to building an open metaverse. Shrapnel. Disclosure, I'm an advisor to this project and I'm being compensated with tokens. Shrapnel is a game under development by Neon Machine in Seattle. This game is going to be integrated with NFTs, blockchain, and so on. Under the hood of this project, there's a lot of thinking and engineering going on that's relevant to the use of blockchain technology, not just in this one game, but in the metaverse at large. Let us imagine a hypothetical case in which someone has written a book featuring a magic sword and wishes to see that sword in the metaverse. The first step might be to mint an NFT that somehow embodied the unique characteristics of that sword. At a minimum, that would be some metadata, its name, what sort of thing it is, its dimensions, quotations from the book, etc., and a picture providing a general template for what it looks like. Call this the stub asset. This would be sufficient for the artist to put a stake in the ground saying, here is this thing I created, and to assert some rights. But in and of itself, it would still be a far cry from a working asset integrated into a game. As such, it wouldn't be capable of generating economic value, since fun experiences are what gamers actually pay for. Games are built on engines. The two most common ones are Unity and Unreal. They use different languages, coordinate systems, units of measurement, and so on. Beginning with the stub asset, it would be possible for someone proficient with a game engine to produce a generic version of the magic sword that would work in a typical game built on that particular engine. In other words, a Unity asset or an Unreal asset. There's also GITF and other standards, but creating a GITF version also requires some effort and some know-how. There are already thriving marketplaces for game assets that can be bought, sold, and used in exactly this way. One can start to envision this as a tree structure where the root asset, the original stub NFT posted on the chain by the artist, now supports multiple branches, one for Unity, one for Unreal, perhaps a GITF. Obviously, more could be added for different engines and standards. An asset purchased on a store and dropped into a game is still a long way from being satisfactorily integrated into said game. Additional work needs to be performed in order to wire it into the game's programming. This will be different for each game. Moreover, each game has its own art direction. The artwork provided in the inherited asset might clash with the overall look of a given game. Developers would have to redo the art in order to make it look right. So the tree has to grow. Additional branches are needed, one for each specific environment in which the magic sword is capable of appearing. In the process, it's possible that a developer might alter the magic sword's appearance to the point where the original creator wouldn't recognize it anymore and wouldn't be willing to bless it as a legitimate embodiment of their idea. Trolls might even produce versions that are patently offensive. Some kind of approval process, therefore, needs to exist so that the original artist can sign off on the new artwork. This is clearly related to what I was talking about a minute ago in the case of bcopy. And indeed, the developers at Shrapnel are admirers of Josh Kramer and the work he's doing on this front. Performing all of this integration clearly involves contributions from artists, programmers, sound designers, animators, etc. If the result turns out to be worth anything, if players play the game and like it, then those people should get paid. The whole scheme goes nowhere if the game makers have no economic incentive to do the work needed to integrate these assets. Since early in 2022, Shrapnel have been working on a smart contract format called Sigma that's intended to do what I've just been describing. This was the case as far back as February, which is when I first heard about this. More recently, the blockchain engineering team at Shrapnel, including Marcus Jones, who is here in the front row if you want to talk to him, have been looking at ways to further decentralize the way that these things are implemented. The traditional NFT scheme consists of some decentralized elements that are embedded in and dependent on conventional centralized technologies. For example, the thing that keeps track of the user's identity is a wallet extension that's embedded in a conventional web browser. When the user wants to change the state of an NFT, for example, transferring ownership to someone else, this extension sends a message to the smart contract, which has some limited ability to execute code. The output of that code goes to a web server, which might typically be running on an AWS instance. This is traditional centralized web technology. The website serves an event back to the user's browser via JavaScript, but a more fully baked version of the process would get rid of the web browser on the user's end and the web server on the other end. The user's wallet application, the thing that knows who the user is, communicates directly with an upgraded version of the smart contract that can execute code inside of the validator node. Results are transmitted directly back to the user's wallet, eliminating the apparatus of web servers and browser. This requires some upgrades to the wallet, but it eliminates all of the traditional centralized web apparatus and seems like it would be a better fit for metaverse-style applications. Agoric, no disclosures here. Earlier in this talk, I mentioned that after Snow Crash was published, I came into contact with people in the tech world who had been thinking about related topics. Several of them had worked on Habitat, an online community from the late 1980s that anticipated many of the features we now associate with the metaverse. They even used the word avatar in the same sense as it was later used in Snow Crash. One of the key things that they figured out very early is that a decentralized metaverse type system is inevitably going to require that you, the user, end up executing other people's code on your hardware. That seems obvious now, but it wasn't then. It's certainly obvious to people who know game engines because game objects can't perform their basic functions without executing code. A typical game object, for example, might include procedural shaders, which are arbitrarily complicated computer programs in their own right. So even in the early 1990s, these guys were thinking about how to make use of crypto to set up computing environments in which arbitrary code from non-trusted sources could be allowed to run on a system without compromising that system. The people I was talking to were Randy Farmer, Chip Morningstar, Doug Crockford, Dean Tribble, Mark Miller, and Doug Barnes, though this is by no means an exhaustive list of everyone who worked on this stuff. At the time, they were developing a language called E, which was intended to solve this problem. Later, Doug Crockford became a leading developer and proponent of JavaScript, which, as you may know, is a foundational element of today's web. Obviously, JavaScript as a client-side language needs to address many of the same basic security issues as E. Currently, Mark Miller, Dean Tribble, and Chip Morningstar are all working at Agoric, which describes itself as an open source development company launching an interoperable proof-of-stake chain and economy. It has been acquired by Microsoft, but as far as I can tell, runs as an independent company. For an interesting readable overview of what they're doing, I recommend a July 8th interview that Dean Takahashi did with Chip in VentureBeat. A key feature of their platform is the ability to program smart contracts in hardened JavaScript. 13 million plus developers know how to use JavaScript, so this would open the door to a much larger community of devs. Quoting directly from Dean Tribble here, the platform has a modern object-oriented framework for rapid composition of applications from the components that other people build. And quoting from Mark Miller, For an open metaverse, the important part of the Agoric stack is that it runs across mutually suspicious platforms, which can serve as separate hosts for different parts of the virtual reality. Finally, quoting from Chip, they are about enabling people in far-flung parts of the world or in communities that wouldn't otherwise interact with each other to be able to cooperate in constructive and beneficial ways. If you lower the risk of cooperation, you get a more cooperative world. By way of wrapping this up, let us return to the example of the magic sword mentioned earlier. Let's say that Alice is carrying the sword around in the metaverse, but decides to transfer it to Bob. At the end of the transaction, it needs to be the case that Bob possesses the sword and Alice doesn't. This needs to be the case even when Alice and Bob move to other regions of the metaverse that are managed by other companies. The transfer of ownership therefore needs to be recorded somewhere on a ledger that's universally accessible and trusted. Moreover, if this transfer was a sale, then money needs to change hands. If this is happening according to the Sigma or similar contract described above, some percentage of the sale price ought to be passed up, what Jaron Lanier refers to as the value chain, to the artists who originated the IP and made it all possible. These transactions, recording events on trusted, world-readable ledgers and transferring money between wallets, map directly onto functionality that blockchains and cryptocurrency exist to provide. Strong arguments can be made, and frequently are, that the same functions can be carried out by non-crypto means. What those arguments boil down to for our purposes is whether the perceived shortcomings of current chains are inherent to all possible crypto schemes, or whether a new one, custom engineered for metaverse applications, can get the job done. For what it's worth, I am betting on the latter, and I hope that in some future SIGGRAPH I can report on what Lamina 1 will have achieved by that point. I tend to agree with Chip Morningstar, who says in that July 8th VentureBeat article, speaking about what they're doing at Agoric, the end is being able to have reliable, trustworthy computation that doesn't require you to have an intermediary who's a trusted third party. Rather, you get the effect of having a trusted third party by an emergent process from the blockchain. We're using blockchain as our trusted computational engine for doing contracts. The growing metaverse is a competitive environment in which blockchain and non-blockchain solutions are going to coexist for a while, just as they do and will continue to do in the economy at large. It's my view that the solutions that thrive are going to be ones that solve practical problems for the creative and engineering talent who constitute the real scarce resource in this economy. Thanks for your attention, and I'll let these guys handle the timing of everything, but I think there's time available for questions.
Yes, absolutely. Thank you.
Yeah.
Thank you, Neal. We do have a few minutes for questions. There is a microphone in the alley if you guys want to grab it and ask question.
Might be worth mentioning that Mark told me when we were getting ready for this that I would be the one kind of Web3-ish blockchain-y speaker. And so that's been the main emphasis of my talk today. In case you all are wondering, this isn't going to be an all-day seminar on blockchain and crypto, unless you want it to be.
Unless you want it.
Yeah.
Are you guys ready to edit your slides and add some NFTs? All right, anybody up for a question for Neal?
Someone, yeah.
Please go ahead.
Michelle?
Yeah, so, the environmental impact of blockchain and metaverse. So the original blockchain, Bitcoin, is famously wasteful of energy and is quite bad, excuse me, when it comes to carbon footprint. And that's an inherent feature of the way it works. It's based on a proof of work scheme that basically can't be implemented without spending a lot of energy. More up-to-date blockchain systems are using proof of stake which, to make a long story short, can be orders of magnitude more energy efficient. So to the point where it's kind of down in the noise. It's not, it's kind of at the same order of magnitude as things you probably do every day. However, you know, any carbon footprint is too much. And so part of what we're doing in the new venture is to build in carbon negativity to the chain. So to the extent that the nodes for Lamina 1 are going to be consuming electricity and possibly putting CO2 into the air, they need to demonstrate that they've purchased legitimate carbon offsets. And what constitutes a legit carbon offset is a vast field of debate and confusion unto itself. But there are people who are in the business of evaluating these things and trying to separate out the good ones from the less good ones. Well, thanks. Thank you.
Manuel?
I think in SIGGRAPH, one of the very interesting things is metaverse was a protocol. So there were things which have to be agreed in public places, and there were things which could run differently into private places as soon you kind of pass a private property. Also, in some of your books, you're having this discussion about like, should we build a metaverse which look like reality? And there is all this talk right now on the metaverse where we kind of in a realistic model, it's always a planet, it's always 3D. But so we can imagine a lot of other universes which don't fit to the same rules. So I know it's a big drop on the thing, but you didn't talk at all about this.
About whether the metaverse can or should be realistic in the way it looks. Yeah, I'm not a believer in any kind of top-down prescriptive approach to what the metaverse should look like. It's got to be a bottom-up. You know, individual builders need to decide what they want and build it. And so I do think that to make a coherent metaverse, there are certain really basic things that have to be consistent, such as the size, the scale of avatars. But I think it's best to keep those kinds of rules to an absolute bare minimum and then let people do whatever they want to. I think that what we'll find, my prediction is that most people want something that's fairly realistic, because it can just become too confusing and bewildering if it's a completely chaotic kind of random environment. And when it comes to social interaction, people want to look a certain way and interact with each other in a certain way. But I don't think that should be a top-down rule. It should be something that's established by people building their own ideas from the bottom up.
Next question, please.
There's a queue at the...
Thank you. Good morning. There seems to be some opposition to smart contracts, and they are being compared to pyramid or Ponzi schemes. Have you ever faced this type of reaction when talking about the economics of NFTs? And what are your thoughts on the matter? Thank you.
Well, I don't think that smart contracts per se are can be linked to Ponzi schemes. I think that as I was saying in the talk, there have obviously been a number of cases in which NFTs were used in basically speculative schemes, where the only kind of the only value that they seem to have is in the expectation that somebody else is going to pay more money for it than you paid. So that's a good definition of speculation. I think the solution to that is to have objects that are of genuine creative and economic value. As I was saying, we have that in the game industry already. the reason that dollars and euros are valuable is because people use them all the time to buy potatoes, gasoline, steel, and so one can feel confident that dollars or euros are a legitimate store of value. If we have an economy in the metaverse where tokens are being used to purchase and trade in game objects, then and those game objects are considered to represent legitimate economic value, then I don't think it's a speculative scheme at that point. Thanks.
Next question, please.
Hello, I was struck listening to you talk about the past and the present and the future, reminded of the 90s and the sort of feelings we had about the internet and how it was all new at the time and it was going to be a sort of democratic upsurge of freedom of knowledge everywhere and a lot of collaboration. And I hate to bring this up, but
it's not.
It's not, and it's awful, and I hate to even say this, but I feel like social media really demonstrated that we don't know what we're doing, like with each other, like how to build this. And I feel like I want to be in this metaverse you're talking about, but I also remember that sort of feeling, and I wondered what your thoughts were on
Right,
that.
is this that again? Yeah, well, I guess the two big things that I worry about are what you just said and carbon. And carbon's an engineering problem, and there's, I feel like I can think about that constructively. The other one is a social political problem, which is harder to engage with. I do think that the business model and the revenue model has a lot to do with this. And so the essence of social media platforms tends to be that they're free to use. And so, as the saying goes, if you're on a website and you can't figure out what the product is, the product is you. So I think that, and Jaren has been incredibly well-spoken on this topic and how the incentives of those kinds of sites tend to create a feedback loop where the sites want you to be emotionally engaged, and what's the best way to do that is to make you mad or to make you scared. So one of the things that I consider promising about the kinds of things I've been talking about here is that there's a transparent economic model in place. And so you're not, as a user, but if I go, the analogy would be if I go to Steam or the Epic Store and buy a game, the economics of that are very clear. It's like, this game looks interesting. Here's some money. Now the game is mine. I'm going to play the game. So there's no hidden incentives or tricky stuff going on. And I would hope that if we can start anew and build a new system while being aware of everything that went wrong with Web 2, that we can address some of these issues as we go along. Yeah.
Thank you.
Thanks.
Okay, so we'll try to go through the last two questions there. So go ahead.
Just a quick one. I was wondering if you can comment on if and what role the government plays in the development of the metaverse.
I think that in a sense they play a role by funding basic research and kind of keeping institutions going. Where the ideas come from. Beyond that, I'm not a reflexive, hardcore, anti-government kind of guy, but I just don't. I think that this is such a complicated and rapidly changing field that I'm worried that even well-meaning efforts by governments to help out would not work, just because they'd be obsolete by the time they made it through Congress or whatever.
Thanks.
And our final question.
Hi, thank you. Thank you for your talk. I was curious because, I don't have comprehensive experience with like portrayals of the metaverse in fiction, but most of the ones that I've seen take kind of a far from utopian kind of perspective of its role in our world. Oftentimes, like at best, it's seen as like it's portrayed as like a distraction from kind of real problems in the physical world. But I'm curious, what do you see as like your North Star in terms of how we should think about like this, metaverse, as many of us are putting together the pieces today?
Yeah, so Snow Crash is obviously a dystopian novel. It's also a parody of dystopian novels. It is trying to be funny. The metaverse is depicted as being not inherently bad or good. We see a lot of the kind of schlocky, exploitative parts of the metaverse in the book, but we also go to the homes that Hero and the character Ing have built for themselves, which are beautiful works of art. So I don't think that I can grant that Snow Crash is a dystopian novel without taking a position on whether the metaverse is inherently dystopian. And I don't think it is. I just think it's a tool. Earth is in Snow Crash 2, which I'm told became an inspiration for Google Earth, but we don't think of Google Earth as being an inherently dystopian technology. So I guess that's my basic stance on that. And I would the only thing I'd add is that distractions aren't bad. They're not inherently bad. Like when we go to a movie or read a book or play a game, or just go for a walk, those could all be categorized as distractions from the problems of the real world. But we do it anyway, and it's not viewed as somehow a harmful activity. I think it can be a beneficial activity if it's not used in a kind of pathological way.
Makes sense. Thank you.
Yeah, thanks.
Well, Neal Stephenson, thank you very much. It was
Thank you.
highly educated. Thank you.